Well, hello and welcome. This video demonstrates the modular architecture of a PLC-based automation project implemented in ABB Automation Builder. The project utilizes multiple POUs categorized into core and complementary POUs to control and simulate the behavior of a tank system interacting with a pump, a valve, a heater, and a mixer. The central focus is the review POU, written in continuous function chart language, which consolidates key system tags and enables efficient data visualization and interaction. The review POU is structured in sections. So let's start by explaining how the mode section works. An additional bit, mean level achieved, prevents low-level alarms during startup. The mode text section interacts directly with the SFC POU. Each mode, offline, initialize, startup, operation, and stability, is represented by a corresponding bit in the SFC POU. The SFC POU also tracks the system's entry count into the startup mode and measures the time spent in operation mode, logging in it as operational runtime in the operation hour meter section of the review POU. The System and Devices Tags section provides system status indicators and device outputs. It includes booleans for system running status and auto mode status for all devices. This section also incorporates control bits for starting and stopping the system and displays the outputs for the pump, valve, heater, and mixer. Moving on to the auto control devices and forced alarm simulation tags, we can see that this section includes some booleans. The control devices that works based on the logic of the system, and the manual alarm bits that are going to be used for taking the system to an alarm condition. It interacts with the complementary POU written in structured text, which calculates activation and deactivation values for the pump and heater based on a raw level and temperature readings. The raw scope POU adjusts simulate rates, heat up, drop heat, fill rate, and drain rate to maintain system parameters within acceptable ranges by controlling device activation times. These values are directly utilized by the simulation logic for level and temperature dynamics, ensuring a stable system behavior. The review POU displays both raw and scaled values for level and temperature. The variable simulation rates govern the change of these values, accounting for environmental and device conditions. These readings provide insights into system performance under various operation modes. The local alarms tag section integrates with the core stability mode POU, written in instruction list. This POU activates when a fault occurs, such as high temperature or low high level. The stability mode POU calculates midpoints between parameter ranges, adjusts system inputs to stabilize conditions, and transitions back to the originating mode once stability is achieved. During this process, it monitors the secondary parameter to avoid triggering additional alarms. The manual alarms simulation tags are programmed within the main POU in structured text. This logic bypasses HOA controls to activate or deactivate specific devices for testing purposes. For instance, to simulate a low-level alarm, the manual alarm tag deactivates the pump and activates the valve to rapidly decrease the tank level. As you have already seen, the review POU serves as a crucial visualization and interaction layer for the PLC system. Its integration with core and complementary POUs ensures seamless operation, fault handling, and simulation capabilities, enabling effective monitoring and control of the tank system.